Hey there, geometry students. Good morning. I hope all is well with you. I'm looking so forward to seeing you again. I really miss you all. I miss seeing your faces. I miss even getting on your cases sometimes when you're not doing right, or just laughing with you or enjoying your company. So I hope that you are all connecting with each other in some way. And just know that just because I'm not seeing you every day doesn't mean that I don't think about you each and every day. So that being said, we've got geometry to do because we've got hope. As long as we're still doing this, as long as we're still planning and learning, we're holding on to the idea that there's hope and that we have a hope and a future to think about. So we keep on learning and we keep on doing, and this is something that you can do to maybe realize that you do have some kind of control over something. You can go on, you can keep on doing, and understand also that you need to take care of yourself and your emotional and spiritual and physical needs as well. So I would encourage you to just kind of look for God around you and be encouraged, and we'll just all ride this thing out together. All right, that being said, we need to talk about angles and circles today. It's kind of a long lesson, but once you get the hang of it, I think you'll find that it's a pretty neat little thing. It's a bunch of little tricks about finding the measures of the arc as opposed to the angles that are made with different lines that go through a circle. So here we have our first thing that we need to talk about, that if you have a circle and you have a tangent and you have a secant, and the secant goes through the point of tangency, then there's some really special traits and relationships between the measure of the arc and the angle that goes with it. The measure of the arc is actually 2 times what the measure of the angle would be. Or we could say the measure of the angle is half of what the measure of the arc is. And here's what that looks like. The measure of the arc is 2 times as big as the measure of the angle that goes with it. Why that makes sense is because, think about it this way, all the way around a circle we have 360 degrees. But these 2 angles together make 180 degrees, which is exactly half of that. So it makes sense that that would be true. So you've got a tangent line and a secant line. These are your 2 ingredients to make this happen. Let's take a look at this for an example. All right, what you can be doing is you can be printing out your own blank pages at home. I would suggest not printing out 1 page per sheet, but printing out like 4 pages per sheet if you have that as a setting on your printer, or if you don't have a printer even, just jot down the things that you think you will need. All right, so we have this right here. We have this circle, and this circle we have a tangent, and we have the secant. That would be a secant if we continued it on, so it still qualifies. Here's our arc length. So what that tells us is the angle TRS from what we just said. I hope that you are making your best guess and thinking that it would be 65, because that's half of what the measure of the arc is. Measure of the arc is 2 times as big as the measure of the angle. The angle is half of the arc. So angle TRS is 65. TRQ. A couple different ways of thinking of that. You can think, okay, I have a 180 degree angle. That's probably the easiest one because 180 degrees, a linear pair. All you'd have to do for that one is take 180 minus 65 and get 115. And I know that there are some of you who think about these things, and before I even say them, you're thinking up the answer. So good job on that. I'm thinking about a few people right now that I just know would be doing that. So good job, good job, good job. And I encourage all of you to kind of pre-think it through. So angle TRQ is 115. Then our last one, measure of arc Rvt. So measure of arc Rvt, right around here. A couple ways of thinking about it. One of them is that you've got 360 degrees, so you could take 360 minus 130. Another one would be, all right, I have this angle, and the arc is 2 times the angle. So if the arc is 2 times the angle, that's 230. Okay, but also 230 plus 130 gives you 360. So either way that you think about it, you've still got the answer for that. So pretty nice little trick that we have for finding angles. And we'll just move right along here and take a look here. I just want to check something right quick. All right, good. Another thing that we have as a trait is that if you have 2 secants and they are crisscrossing in the middle, okay? So 2 secants that are crisscrossing in the middle, what that makes is a situation where really the angle in the middle is the average of the arc lengths, okay, or the, not the arc lengths, the measures of the arcs. Because remember, going right to the center, okay, central angle equals the measure of the arc. Okay, this is not a central angle though, so it's not quite that simple. But if you take the average of the 2 arcs, in other words, divide them by 2, you get the measure of this angle right here. So angle 2 then would also be able to be found. Angle 2, though, would be the average of this arc up here and this arc down here. BC plus AD would give you that one divided by 2. So angle 2 is the average of these 2 arcs, and angle 1 is the average of these 2 arcs. So we're thinking about if it lands like right on the edge, like we did a minute ago, all you're doing is dividing by 2. But when you've got 2 lines and they go in the middle somewhere, you've got to add and divide by 2, and we get our answer. So let's look at a problem. Okay, we've got this problem, and if you need to pause to sketch it out, you can do that. We're trying to find angle 1. We're not actually given this arc over here, so we're going to have to do a little bit of finagling to get there, but you can do it. I'm going to bring up my blanks so that we can work through. Okay, in finding angle 1, we have to do some other things first. First of all, we need to find this missing angle. It wasn't part of the question, but we can find it easily because we can take 32 plus 54 divided by 2, and it's going to give us this angle. 32 plus 54 divided by 2. Remember, the average of these 2 gives us this one. And here's our 43. Now, hopefully, little bells and whistles are going off in your mind as far as, oh, okay, now I have this angle. I can find this angle because all I have to do is subtract from 180. And when we subtract from 180, we get the answer to angle 1. And that works out great. Okay. So we found angle 1. Notice I've got, if you want to check out things, you can think about other things that you know in order to check to make sure your answer works. In other words, all 4 of the angles should end up making 360. They'd have to. So if we add all those up, and yes, not drawn to scale, and I know somebody that's bothered by that, but nope, not drawn to scale, but 182. And if we take 360 minus 182, that gives us this angle. And in order to check and make sure that our angle 1 is right, or this is actually an alternate method of finding angle 1, if you add these two, 178 plus 96, and divide by 2, we should also get that same answer of 137. And it works out like that. So you can either use the green and orange method or you can use the purple method here. Either one, you're going to find your 137 for your angle 1. All right. So far we've got two things happening. We have where the two lines cross each other and they land like right on the edge of the circle. We have here where you've got the two lines cross each other and they land in the middle of the circle. The other thing that happens is when you've got the two lines intersect and they are intersecting in the outside of the circle. Okay, and that leads us to our third formula for the day. And most of what we're doing, actually all the stuff we're doing is based on those three ideas. So here's just our third idea for that. So if you have a circle and you have two secants, or you have two tangents, or you have two of somehow that they both intersect the circle in one way, a secant and a tangent, the way that you find the angle that's made is by taking the bigger one minus the smaller one and dividing by 2. It's not really an average, but since it's crisscrossing outside the circle, it ends up working out like that, okay? So if you've got them crisscrossing outside the circle, but they both intersect the circle in some way, you take the bigger arc minus the smaller arc divided by 2, and that'll give you the angle measure. That works for a secant and a secant. It also works for a tangent and a tangent. You're still going to subtract and divide by 2. So I have this arc ACB minus arc AB divided by 2 will give me this angle. And finally, it also works if you have a tangent and a secant. The key is that they're intersecting outside the circle for the subtracting one. Okay, here's another one, the subtracting one. You've got the two, a secant and a tangent. They intersect outside the circle. Here's the arcs AB minus AC. This one minus this one divided by 2 gives you the angle. And once you know these things and you're thinking about your formulas, you can then do problems that involve these concepts. So here, if I have this one, let's do our first problem with it. We have a secant and we have a secant and they're intersecting outside the circle and we're trying to find our little angle here. This would be like our angle 1. We have arc, the measure of arc AB equaling 30, the measure of arc DC equaling 80. Some of you've already done this problem already in your head, so please make sure you do the homework problems as well. Then that way it gives you a chance to do more. You know, you're only writing down the notes that you need to for this. So what we're doing for this is you would subtract 80 minus 30, divide by 2, and it would give you 50 divided by 2, which is 25. So you've got your measure of your angle is half of the difference of these two arcs. You're always taking the bigger one minus the smaller one in order to do these. Okay? Remember, so crossing outside is subtract and divide by 2. Crossing inside is add and divide by 2. And crossing on the circle is just divide by 2. Okay, so we'll go through these things a few more times. Here you've got crossing inside the circle. So let's think for a minute, which one would that be? Would that be add, or would that be subtract, or would that be just divide by 2? Okay, wait a minute. Crossing inside the circle almost kind of looks like a plus sign. Yeah, that's it. I'm going to add for that one because it kind of looks like a plus sign when they cross inside like that. So I'm going to make that mental connection. And so yes, for this one you're going to add and divide by 2. And that'll give you your angle BMA. All right, do make sure that it's the intercepted arcs, and this is the angle you're trying to find. If you were trying to find BMS, you would have to then subtract from 180, but you've got the basic idea to find these, and you end up with 67 degrees. Okay? All right. Now moving along to the other, and I understand that there's somebody who's got who's not writing too well right now. You got a little bit of an injury possibly going on, so I'm praying for you. I'm not going to use your name because I don't want your name out there, but you can still watch, and hopefully you're watching. So if you are, know that I'm praying that you get better quick. And but for right now, at least you can watch and understand, and I think you can understand it because you're pretty awesome. All right, and if you don't know who I'm talking about, that's just fine, but the person who I'm talking to knows. All right, be very blessed. And let's move on and look at another one. All right, so here we have another one. This one, the 2 intersect on the circle. So we need to think that through a little bit. This is a very sloppy, the measure of arc MA, which is here, is 110. And so we need to work our way through thinking what happens when they intersect on the circle. Okay, when you intersect on the circle, you've got an arc. It doesn't intercept 2 arcs, it just intercepts 1 arc. So this is the one where all you do is divide by 2. Okay, the arc is 2 times as big as the angle, so you just divide by 2. And when we divide 110 by 2, you get 55. 110 divided by 2, 55. So 55 degrees in here. And now this says Arc ATM, so you have to think about, here's the end. Here's our arc ATM. So we're thinking about an arc here. We have not figured out this angle yet. That would be easy to find, the angle, and then multiply by 2. The other thing you can keep in mind is 360 degrees goes all the way around. So I have 110 here. So I'm thinking it would be very easy to just take 360 minus 110. And that'll give you 250 degrees for this measure of this arc right here. And then angle MAN, angle MAN, you can either subtract from 180 or you can divide 250 by 2. Either way, you should get 125. We can check this. 125 plus 55 does equal 180 degrees. So all of these concepts work together and should make sense. So once again, intersects on the circle, you just divide the arc by 2. Intersects in the circle, you add and divide by 2. Intersects outside the circle, you subtract and divide by 2. All right, here's another one. All right, this one, you should be thinking, okay, this is an add and divide by 2. It is. But you have to think about what you're adding and dividing by 2. You add the arcs and divide by 2 to get the angle. So if you're trying to find x, you set it up with the same thing I just said. Add and divide by 2. And when you add and divide by 2, you get the angle. So here we have a variable, so you have to go back to algebra a little bit here. We need to multiply both sides by 2. Okay, multiply both sides by 2 in order to get this by itself, and then subtract 44 from both sides to get your 92. Okay, I know that you've had this type of math before, I'm not sure exactly when that started, but I know that we're doing problems that are somewhat like this in pre-algebra right now. But that does fall under the algebra category, so just remind yourself a little bit of your algebra skills. Multiply both sides by 2, and then subtract 44 from both sides, and we get a 92-degree arc here. Okay, so thinking add, divide by 2, but remember what you're adding. This one. All right, I see this picture. Are you thinking add? Are you thinking just divide by 2? Are you thinking subtract? We're going to think subtract and divide by 2. It's outside the circle, okay? Outside, and so we're going to be thinking subtract. But once again, we have to figure out what exactly we're subtracting. So we fill in our known information. Oh, that's blurry. Our known information is that this is 124. I don't really have a way of clearing that up because it's a resolution problem with the picture. 124 degrees right here. Sorry. And then what we can think about is this bigger arc, the big arc right here, the major arc. Remember, 360 degrees total. So we can figure out this major arc by subtracting from 360, and we have our second piece. Remember, out here we're trying to find angle ABC. We're trying to subtract and divide by 2. But you had to figure out what the second number was to subtract first. You had to take this one taken away from 360. Now you've got a bigger number and a smaller number. You subtract them and you divide by 2. And giving you 56 in that calculation. Okay. And you can see on the little thing on the side, you're probably like, oh, okay, we're doing another subtract and divide by 2. Yes, we are. Do follow it through to the end, though, because this one's a little bit different. This is the trickiest one, but you can do it. Okay, because we're supposed to be finding measure of arc AB, and we're given the angle this time. So we need to choose a variable to represent arc AB. So I'm choosing my variable x to represent arc AB. Once you've got this as arc AB, the major arc that goes with it, if you remember from the last problem, how we found it was we took 360 minus how much this was. So we can't find the actual number, but we can get the expression 360 minus x to represent this part. We're still thinking of subtract these two, divide by 2, that equals our angle. So 360 minus x minus x. Don't forget the minus x part here. 360 minus x is this big arc. X is this small arc. Be careful with that. Now the other thing to be careful about is when you take away one x and take away another x, you have taken away 2 x's. 360 minus 2x. It's very easy to lose one of these x's here, but you haven't taken away one x, you've taken away 2 x's. And then our algebra tells us to multiply both sides by 2 and get 76. Our algebra skills tell us to go ahead and subtract 360 from both sides. So 76 minus 360 gives us negative 284. And then finally our algebra skills tell us to divide both sides by negative 2, which gives us our final answer of 142 degrees. So I know you can all do all those things. Thank you for listening in. God bless you. I can't wait to see you again. Have a great and wonderful day and keep on learning. Learn something today. Learn something that you can just tell somebody that's just really cool, even if it has nothing to do with math, but you see something, just learn something today. And understand that you're created to share things. So share what you learned with somebody today. All right, God bless.